is being recorded.
Evening and morning, everyone, and welcome to the 13th episode of VizConnect. We are just 10 days away from Tableau conference. I'm excited about that. So today, I'm excited and thrilled to introduce today's speaker. He's a Tableau Zen master and author of Big Book of Dashboards. Everyone, please welcome Jeffrey Shaffer. A brief introduction about him. Jeffrey is a Chief Operating Officer and Vice President of Information and Technology and Analytics at Unifund. He is also an adjunct professor at the University of Cincinnati Visualization, where he was the 2016 Outstanding Adjunct Professor of the Year. He is the author of the Big Book of Dashboards, and he's a regular speaker on the topic of data visualization and Tableau training at conference, symposium, and workshops. He was a winner of 2014 Tableau Quantified Self-Visualization Contest, which led him to the compete in 2014 Tableau INVIS contest. His data visualization blog, Data Plus Science, and the Big Book of Dashboards, one of the shortlists for Kantar information, is beautiful awards, and his beautiful trash visualization was one of the longest and featured as one of the 75th best infographics of 2017 by Column 5 Media. And the fun fact about him is that he used to be a professional musician, a classically trained trumpet player. Over to you, Jeffrey.
Thank you very much. It's a pleasure to be with you all today. My topic today is going to be maps, location, putting your data on the map. And just as a kind of an extension of that introduction, I appreciate that. It was a great introduction. So I think we've covered all of these things. My contact information, you can find me on Twitter at HighVisAbility. And my website is dataplusscience.com, so feel free to reach out with any questions or just in general. I have been teaching at the University of Cincinnati for about 7 years now. I've had over 1,700 students, and they have actually all used Tableau, interesting enough. We've used Tableau since the beginning of our course at the university. My website, Data Plus Science, I will just point out to you that there is a button, in addition to my blog, there's a button called the Tableau Reference Guide, which has curated links that you might find interesting and helpful to you. Not things that I just wrote, but from around the community. There's about 760 different links to Tableau things, and there's entire sections on there, including a mapping section, but there's entire sections for calculation and color and chart types and all kinds of things, and it's searchable. You can go to TableauReferenceGuide.com or just go to my website and click that button. You mentioned the Big Book of Dashboards, and I'm one of the 3 co-authors on the Big Book of Dashboards with Steve Wexler, Andy Cotgreave, and we have a separate website, bigbookofdashboards.com. I would encourage you to check that out because there's a dashboard tab on that website that has not all of them, but most of the dashboards from our book. You can actually download the Tableau workbooks and see how they were built, and this is really meant for you to have inspiration in your own work, so check that out. We've been very pleased that the book has done really well. Actually, it's been a #1 bestseller on Amazon in the enterprise applications on and off. But funny enough, it has also been removed at one point because of the Mueller report. Somehow ended up in enterprise applications, and so that was kind of funny that the Mueller report took #1 away from us for a little while there. I guess it was more popular. I don't know. So our topic today is maps, and maps have been around for a very long time. They've been around a lot longer in our history than charts and graphs and even other forms of visualization. We can go back to maps on tablets as early as 600 BC. Earliest known map on a clay tablet, a Babylon map. We fast forward, maps have been used throughout history. A beautiful map here from circa 1400. There's a great website, the David Rumsey Historical Map Collection online, and you can really view maps through the centuries. And it's a really open to the public source, and really you can explore some of these maps. I just pulled a few of them for you to see the beautiful detail. Keeping in mind this is, before tools like Tableau and Map Box and computers in general, people were doing these by hand, and then later copper plates and other, technologies of their time, and really amazing the detail that we have. This one is fascinating to me, Great Britain's mapping of rivers and streams in 1848. And it's so detailed that it really gets into 1,550 rivers, 440 lakes and ponds, 40 waterfalls, and even a notation on this map that the length of rivers are drawn to careful original calculations. So just imagine at that time trying to draw a map with that level of precision, and look at it. It's really beautiful when it's all said and done. There's also some very important maps in our history. One of those important ones would be by Jon Snow, not from Game of Thrones, but in 1854, Jon Snow created this very simple map that really changed so much. Really, there was an epidemic out in London, the cholera outbreak, and by putting a very simple map together, really kind of showed, you can kind of see the bars, the black bar charts, if you will, where incidents were occurring. He was able to narrow this down to areas where there was a water pump, and by realizing this, found sort of the source of the problem from a very simple map. Charles Menard, some of you may know from Napoleon's map of invading into Russia. He mapped lots and lots of things. This happens to be the meat production in France, in the various provinces of France, and this is the mid-1800s. More famously, his Napoleon map that I just mentioned shows the advance of Napoleon's troops invading into Moscow, and this is a map. It's overlaid on a geographic field. That's why it kind of has that weird shape to it, mapping the number of troops going into that invasion and then ultimately retreating back. Another beautiful map from our history. About 1895, two ladies, Jane Addams and Florence Kelly, are really doing the first demographic maps, sort of from an economic standpoint, and they're plotting income by household, and they're plotting nationality, and this is in Chicago, so this is a street map level of Chicago, and this one is mapping the homes in blue that are Italian versus the ones in brown that are French or orange Chinese, and you can kind of see the diversity building here in the Chicago neighborhood street by street, but yet you can also see the pockets of 3 blocks or 4 blocks of sort of the Italian neighborhood, right? And this, again, done so long ago. Beautiful, beautiful map. The University of Cincinnati, interesting enough, where I'm an adjunct professor, was the first university to create a co-op program. And so in 1906, the dean founded a co-op program, which is, really interesting history for us. And in our historical data visualization books, one of the famous visualization authors is Willard Britton. And Britton did a map in his 1918 edition of Graphical Presentation, which has become a famous data visualization book. Sure enough, his figure 187 looks at the locations of plants affiliated with the University of Cincinnati related to these co-ops. And so that's very interesting, just 10 or 12 years after the program was founded. There's another famous map moving into the 1900s. We have Beck's London Underground map, and this map is really a living map because the stations in London changed year over year. Really a lot of variations, right? More stations are added, train stations, and sort of the community as it builds out. And so this is another interesting one. There's an entire book of this from its origination, its first version of the map into modern day. So very interesting, and it still lives in some form today. So why are maps so powerful? Maps encode lots and lots of data. We can encode using color and size and position and path to show data geographically. If a picture is worth 1,000 words, then I would say a map is worth 1,000 cells. We can take 1,000 rows of data and plot that on a map very, very easily and quickly. It's one of the beauties about Tableau is its mapping capabilities. We can do this by state, by a county, by a zip, by a block, even down to an address. We can put a point on a map, which we'll see in a few minutes. We can color a map by, say, state. In the United States, this is the unemployment rate by state. We can look at profit by state, a variation of color where we use a diverging color scheme. We can put dots on a map where we have lots and lots of locations, say visitors to a website or down to an address, which we'll show in a minute. And even locations of our company are, in this case, hotels that might be properties across the world and want to see where those properties are. I am not going to play this video because I'm worried over the WebEx that it won't play really well with the sound, but I would encourage you to check it out on YouTube, and I'll provide a link when it's all said and done. But it's a great video called 42 Amazing Maps, and it's a lot of fun. It's just about a minute and a half, and worth your time to check out, and talks about all the variations of the different mapping. But in the interest of a WebEx and sound and delay, I'm just going to move over that. So that'll move me on to mapping mistakes and talk about mistakes in mapping. And this isn't anything new. We've been making mapping mistakes for a very long time. Interesting enough, even some of the historical maps for a long time have had some of these mapping mistakes. This map that you see now is of West Africa in the 1800s. It's included in what's called the Mitchell School Atlas. So this is an atlas that we're teaching kids about mapping, right? Geography. And so it's in the school atlas and was in there, interesting enough, in there for over 100 years in some form or fashion in an incorrect way. Here is right in this area, you'll see where it says Mountains of Kong and sort of these dots that represent this mountain range going across West Africa. And in other maps, this one here, I actually own this map from 1815. The mountain range is really pronounced. It really shows across the whole range of West Africa where it says the Mountains of Kong or the Mountains of the Moon. And you might ask, well, what's so wrong about this map and in this particular mapping mistake? Well, the thing is those mountains don't actually exist. There is no Mountains of Kong. They were using records of old where people had thought they've seen mountains, but as we move into the 1900s, the mid-1900s actually, people realized there are no mountain ranges there. At best, there may be some hills, but it's pretty flat throughout all that area. There certainly isn't a giant, Rocky Mountains or Appalachian Mountain Trail dividing West Africa up in any form or fashion like that. You might say, well, sure enough, in the old days, maybe they made those mistakes. Maybe it was just back then. But I assure you, it's not just then. This is Fox News in 2012, so not too long ago, mapping something that happened at the University of Texas, and they had to evacuate the university. What's interesting about this particular map is over here on the right-hand side, where they have mapped Missouri, Alabama, and Mississippi, and didn't get those correct. Those are not actually those states. Those states are completely mislabeled. All three of them are wrong. So we like to joke on this one that maybe Missouri has invaded Arkansas and Mississippi and Alabama have switched land. I guess they've traded states because they're completely backwards. Other mapping problems just have to do with the fact when you map data, you're always making a compromise in some form or fashion. And maps really kind of hit that home. In data visualization, we often make compromises, but in maps, we're always making compromises in some form or fashion. Nothing hits home like that, like our Electoral College in the United States, where from our 2012 election, you would say probably the red team won because there's more red than blue. But in fact, that's wrong. It was actually the blue team that won that election. And so when you look at something like this, you're actually not looking at the Electoral College by state. You're actually looking at the electoral number times the size of land that that state might have, and that distorts it. So states like Montana end up with a lot of red when they don't have many electoral votes. There's other solutions to that. We could use circles maybe to size for that, but that's another compromise that we're making on the map. Other people have tried variations of sorts. Mark Newman from the University of Michigan created a cartogram and tried to show this data. Very hard to figure out which one is your state or what's going on in that data, so probably not a good idea in that instance. Other variations, my co-author, Steve Wexler, created a tree map of that data. Not a map at all, more of a chart type, but a tree map invented by, or sort of popularized by Ben Schneiderman. This is a good solution for that Electoral College because you can see that the blue team is a little bit more than half, and you have a bar chart down there, and you can see actually 332 against 206. So it's pretty obvious that they have almost 2/3 of the votes here, and easy to see, and you can kind of see that it's more than half. Other mapping types might include something that is a little bit away from a map in what you might consider. Tile maps are an example of that. In this particular example, I have our complaints dashboard. This is a real dashboard in my company, and in this particular dashboard, I'm showing complaints. Any consumer business would probably have complaints of consumers that they have to handle. And what's nice about this type of map is that all states are equal. California holds no additional weight over Rhode Island or Maryland or even D.C. If you had it on here, or Hawaii. And so all states are equal no matter how you're handling it. Your compromise in this map, though, might show where the states are not exactly where you would expect them. For example, West Virginia is not southwest of Ohio, and Maryland is not southeast of Ohio. So you have to make, these compromises of where the position is. Kentucky, for sure, is way off from Ohio in this particular layout. So these compromises, again, you're making a map compromise here, but maybe for the purposes of another reason to try to make those states equal. Tile maps are also useful because you can put other dimensions in them. For example, you could put time elements in there. This is the national parks visited across the states, and we can see another dimension. Not only do we see the location, approximate location of where these states are, but now we can see North Carolina, the Blue Ridge Mountains are declining with the visits, while the Golden Gate Bridge in California is increasing. So that's another element that can be added to these maps. It was Halloween last night, and some of you may not know I track my trick-or-treaters. I have a public data set actually available on my blog where I've tracked my trick-or-treaters for about 10 years. And last night I had 523 trick-or-treaters show up, even though it was a bit cold outside. So in honor of Halloween, I thought I would share this one, which is a data set that was created by estately.com and visualize their data to show, would your state survive a zombie apocalypse? So something just for fun. I should point out to you all the maps that I'm sharing on this webinar were all created in Tableau. So I probably took that for granted, but or just assumed you would know that. But I think everything except one map toward the end I created in Tableau. So this is a Tableau viz on my Tableau public page. In this case, I guess if you want to avoid the zombie apocalypse, Alaska or Montana would be a good state to visit. Other fun things, I did not create this particular map. This is on popversussoda.com, and it's what we call soft drinks in the United States. And do you call it a soda, do you call it pop, or do you call it something else? And now we're visualizing data by county, and very different the regions of the United States, the north versus the south versus the west or east coast. Sometimes our data might have another shape to it, and in this particular data set, this is school districts where it doesn't match a county or any other boundary line. It has its own defined boundary line. Tableau deals with this in a couple of ways. You can bring in polygon files and draw polygons, or shape files, and you can bring in geographic shape files. And so there are shape files of these custom boundaries or other features of maps. And this is an example of that, maybe performance by a school district. Dots on a map. This is 92,000 branches, bank branches in the United States, mapped with no map layer in Tableau at all, just a blank canvas, which is really interesting because it kind of shows the population of the United States. We put branches where people are, I guess, same as probably where you would put McDonald's or Walmart's or anything else. So there's probably not much interesting about this map in general. I could have labeled it the Verizon coverage map, and you might have thought it was a Verizon map. But when you start applying other things, especially things that Tableau is really good at, like filters, you could filter down this map and you might find other interesting trends about it. For example, if I looked at Wells Fargo or JP Morgan Chase, and I started filtering by those bank branches, then that might be interesting. And if I filter down further into the other branches, then I can find even more interesting data like numbers 5 through 10. I could look at Fifth Third is based in Cincinnati, and where does Fifth Third look and their region. And now I'm getting interesting data out of this map because of applying an interactive feature to it, right? I can even look at where those banks would maybe potentially look to acquire one another. Now, interesting enough, SunTrust and BB&T have done a merger, or will be doing a merger. So SunTrust was actually acquired or will be merging with another bank. But SunTrust might have been a good acquisition for somebody like U.S. Bank, just based on their geographic footprint. It might have given them the expansion that they might have wanted in branches. So another interesting aspect about that. Mapping can take on another aspect where we're not mapping geographic, but maybe we're mapping things in a factory. This is a Tableau dashboard done by a VizPod, which is a consulting company here locally in Cincinnati called False Peak Ventures. And this dashboard that they built for a client is a robotics dashboard, and it shows production on a factory floor where productivity is happening, and is one unit of the assembly line producing better or worse than another unit, for example. Not sure how the animation will be playing on this one, so I'll let it play for a little bit. But this is badge swipes at my company. You'll see the back door that kind of lights up red periodically is where they're coming in, and we can kind of see the employees badging over time. So again, a variation of mapping where we're mapping a building footprint, and we can put the coordinates and the data to the building footprint. Moving back toward a geographic map, these are customers of the Cincinnati Zoo, and looking at their membership. Do they drop their membership? Do they remain active in their membership? Do they let their membership lapse? And certainly in the area near Cincinnati, more active membership. What's interesting though about that is if we drill down further into the details of that map, then we'll see other interesting trends, even maybe down to the neighborhood. Neighborhood on the east side of Cincinnati shows very high actives, where over on the west side of Cincinnati you have two different areas. One that has high actives where they keep their membership year after year, but then just south of that, areas near the university where people might just let their membership lapse because maybe they're students coming in and out of membership. So you can kind of see those different pockets of the areas across the city there. Our city of Cincinnati uses Tableau. This is their one of their public dashboards on Tableau Public. They put all their data out there. They have a great website called Cincy Insights, and this is right now we're going through a period where we have sort of an opioid epidemic going on in the region, and so they were mapping the incidence of heroin in our city and putting that on a map. As part of our Tableau user group here in Cincinnati, for the last couple years we've been looking at this data and doing some interesting projects. One of our local leaders of the members of our Tableau user group, Spencer Bauke, did this really great viz. He's a consultant now for a group called Tessellation, and he did this beautiful viz on the Cincinnati heroin epidemic and did a lot of mapping in relation to this. He mapped the heroin epidemic in our custom areas, neighborhoods of Cincinnati, and you can kind of see the different neighborhoods. He did a top 10 of those neighborhoods, mapping them again using a shapefile of those neighborhoods, and then ultimately drilling down into the points of those incidents so you could see right there a dot on the map. As part of that effort, my good friend Alan Walker, who's out in San Francisco, he works for Map Box. And Alan created a set of maps mapping the heroin epidemic for us. He did a hotspot location, kind of looking at where those incidents are happening. And then he went a little further and said, well, what happens if I look at the distance that those incidents are happening from, say, the police stations and then the hospitals? Ultimately, where are they mapping to the hospitals? And so he really dove right in. I mean, this is really beautifully done. You can see a hotspot area, you know, sort of over on the right side of the map where there's a lot of incidents in that neighborhood over there, that area of Cincinnati, and yet, you know, from a driving distance in miles to the hospital, they're very far away if they need to get help or if somebody needs to get to them. And then you can kind of see downtown where we have lots of hospitals and where those areas are. So really well done. This was using Mapbox inside of Tableau with the Cincinnati data. Anya Ahern, Alan Walker, and I did a presentation back in 2015 at the Tableau conference, and we included some mapping of some crime data and found another interesting pattern of drug overdoses in San Francisco. And so we mapped that in an interesting way where you can make it interactive, click on the map. There is a embedded Google Map Street View built into this. So now we have a map inside of a map, and we can click around and kind of see the variation and play with it, right? You can kind of see, look around on the upper map to get your selected points, but really dive into detail on your satellite view or your street view, in this case, of your map. We also mapped the people coming to the 2015 Tableau conference. That was in Las Vegas that year, just like it is this year coming up. And so we mapped that as an attack on Area 51 just for fun. That's not actually a missile attack, but we just plotted the cities that the Tableau conference attendees were coming to. This is a recent technique with our make line and make path in Tableau, and connected that up to create interactivity where I have direct flights coming out of Cincinnati, and then wherever that flight lands, clicking whatever city and showing the flights that then go from that airport. So this uses set actions along with the make path and make line functions that are relatively new to Tableau. And along those same lines, this is a viz that was recently on the long list of the Kantar Information is Beautiful. It's on my Tableau public page, and you can click through that. It is really about campgrounds in the United States. You pick your airport in the United States, and it'll give you direct flights. And when you figure out the flight to the city, the destination, you can look at the campgrounds in those areas. So along the same lines, it uses some of the same techniques, make line and make path, and in this case also has a tooltip that you hover over and has a map inside of the tooltip. Some tools I've built, this is a while back, trying to figure out if we can get a GeoMidpoint using set actions in Tableau, where you select any number of points and maybe you want to know where to put a location. You want to build a location for your customers. You know, your customers are located in a certain area. Maybe you want to put a store there or a restaurant, or maybe you want to move locations, or you just want to see the center of the activity. And so on the fly, using set actions, this will calculate the GeoMidpoint of latitude and longitude to tell you where that midpoint is for those selected dots. I think it was on the Tableau forums or maybe Twitter that somebody asked, can we figure out the nearest ocean from any given point in the United States? And the answer is yes, we can do that. First, you need to know what those points are, and so I didn't include the Great Lakes here, just the oceans, which was the question. And based on any latitude or longitude or predefined cities in the list that I put in there, you can figure out exactly straight line what's the closest line to the ocean. And recently they've added distance calculation that works with a live connection. You could calculate this even easier. Another example of some of the new features in Tableau, I've created a circle radius where we can set the mileage and pick a point, and then using collapsible container, have another satellite view in another map off on the side of the viz. And so this gives us a bunch of capability. Number one, we can click on any point in the map and it'll give us that radius around whatever circle we've defined. So those are the points that are within a 3-mile radius. Then as I move around, the points will move and the satellite image will adjust, and then further, then I can drill down into that satellite image with, you know, sort of a custom zoom feature. So that uses a lot of things, set actions here, and some other tricks with collapsible containers and some distance calculations. I do have a blog post on building that if you're interested in that one. Another technique I did was using parameter actions and bursting dots so that we can start with a large circle of dots in an area and break that down into neighborhoods, and then ultimately burst that down into individual points and see the incidence so that it doesn't take up a lot of room on the map. And then some very simple and easy ones to build. Zip code is probably one that comes to mind. Tableau handles zip code very, very well. Double click a zip code with some data and you can get a filled map. I looked at the average commute time to work and found some interesting things in especially some of the cities that have higher commute times. Atlanta, for example, has longer commute times, and Los Angeles, which has longer commute times. Cincinnati actually not so bad until you get to some of the areas down south. But when you compare it to some of the bigger cities, you can kind of see how their traffic looks. This is a real data set that I think it was Josh Tapley who posted this one. It was incident rates of cancer and how they were increasing, and caught my attention when he posted this a few years back, especially the red areas around Kentucky that kind of pop out on the map. And so I decided to drill into that and see what was going on in there. And so drilling down into that, I found Owsley County, not too far from Cincinnati actually, had the highest increase of cancer in the United States, a 46% increase of cancer over this period of 34 years. And it's really interesting how did that happen. And so I dove into that data a little bit. I looked at things like life expectancy, which, interesting enough, 30 miles down the road is 10 years longer than the set of counties that are sort of down in the southwest corner of Kentucky. And I looked at some other data as well. I looked at smokers, for example, because smoking, can lead to cancer, can cause cancer, and so I thought about that. Maybe smokers were causing that. I didn't know where Owsley County was, and so I put Owsley County on a map, interesting enough, a Google Street Map, and I found, didn't know where this place was, didn't really know anything about it, and saw a coal truck, and so that piqued my interest, and I started looking around the Google Street Maps only to discover that the coal truck that I had found is actually on the street map for about 20 or 30 miles. The Google car actually follows the coal truck down the street for a very, very long time. And so that kind of indicated, hey, maybe you want to look at coal. It looks like this is probably a coal town of some sort. And so I did that. I looked at surface coal mines, and sure enough, that area of Kentucky is very heavy with surface coal mines. And then I looked at all coal and just said, well, maybe it's just coal in general, all coal mines. And sure enough, that area down there in the bottom, sort of south east corner of Kentucky, and over to the southwest, I guess, in the Evansville area, they're heavy coal mine areas, and so very interesting. And when you line that up against life expectancy and those areas that had the cancer, you'll see that sort of overlays really well. And I did find some things on the internet as well about if somebody smokes and is working in a coal mine, that the chances of cancer are off the chart. So that's interesting. Tableau also gives us the ability to use shapefiles, as I mentioned before, and shapefiles are prevalent on the internet. Just search for various shapefiles and you can bring them right into Tableau. I built this particular map of rivers and streams in about in less than 3 minutes. You really just bring the shapefile in, double-click geometry, and it maps, right? And so it's really, really easy to do things like this. And again, this has no map layer on it whatsoever. This is just mapping the rivers and streams. So shapefiles are wonderful, and we can do lots of things with shapefiles. The New York Times mapped droughts in a small multiples. I love this, and small multiples is a great technique, and it works really, really well with mapping. So now if we don't have the ability to have interaction, maybe we're creating a static form visualization, mapping can work really well with small multiples. And in this example, we can kind of see where this 10-year period or 20-year period didn't have droughts versus 2012, where there were lots of droughts. The water crisis in Flint, Michigan, I mapped that, the boundaries of the various neighborhoods. You can see the neighborhood on the south, sort of southeast, did not have as much problem as the neighborhood in the northwest in this case. So that's an interesting analysis. I mapped for a large banana company. They were interested to see where they would put banana plantations, and tropical storms and tornadoes and other coastal weather patterns are very interesting to them. So tropical storms, mapped all the tropical storms and hurricanes and looked at those, and interesting enough, in the areas where you could plant bananas, it's interesting that one possible location for planting those are in a very high volume area, and another location where you might plant those bananas, it doesn't have tropical storms hardly at all. And so that was interesting to them. Now they have other things that go into that decision, cost and other factors, but from just a standpoint of storms, the choices that they have to put these are interesting when you plot that on a map to see what that looks like. Other shape files that I'll just kind of show you quickly and kind of talk through them, and I hope the sound is going to click with my slides transitions here, but these are the Cincinnati Buildings. So these are shape files of all the buildings of Cincinnati, and we have all the sidewalks of Cincinnati, Xavier University, not too far from the University of Cincinnati. These are just the sidewalks mapped with the streets, so without the buildings. And I did a traffic viz that I can share with you. This is on my Tableau public profile page, but that uses a Mapbox map and then overlays traffic. One of my co-workers here in the office, Michael Chin, who works in our IT department, he was going down to a light festival here in Cincinnati called Blink, and so he decided to map all the Blink locations using a beautiful Mapbox map in Tableau. And what's nice about this, he even drilled down. The tooltip had the images and all of the information about the light show, so that was kind of fun as well. I took the open data Cincinnati data and mapped all of the traffic accidents for drivers 18 to 25. I call it the young and the reckless. And this is right around the University of Cincinnati. As you can imagine, the students, young drivers, a lot of traffic accidents. So map that in our new mapping features in Tableau. This is a shape file of our snowplows in Cincinnati on a really bad snowstorm earlier this year, January 14th to the 16th. We had, or 11th to the 14th, excuse me. We had bad snowstorms, and this shows the routes of the snowplows. And again, this was done in a shape file, easy to bring this into Tableau with a couple double clicks. Cincinnati is on the 7 hills. And so this is again, Tableau with Mapbox. I brought in a Mapbox map of the hills just to kind of show the elevation in Cincinnati of how our downtown area is actually on the water, but all the areas surrounding Cincinnati are elevated up on the hills. This is a map of cell phone towers in Cincinnati, the actual locations of the cell phone towers, lots and lots of cell phone towers, and right around you can kind of see the freeways and how the freeways are going. Kind of looks like a map from Stranger Things, actually, but a lot of the cell phone towers. And the next one is a project of real work with a major cell phone provider who buys cell phone towers from auction, and so they wanted to map the shape of them, and so they asked if it were possible to create the shape of the signal for each of their towers, and the answer was yes, with a little math in Tableau, like you would do a radial bar chart or some other polar area diagram or something. We use that math, and we can create the shape of the different cell phone towers that they bid on at auction. And we can even map those on a map and show where those cell phone towers are and the shape of the signal for each one of those. I did not know until this project that those cell phone towers had vastly different shapes. Using New York data, open data in New York, 231,000 no parking signs in New York. So I call it the city that never parks instead of the city that never sleeps. And we can even drill down into the blocks and show where on the street those no parking signs are. This uses new features in Tableau around density marks and then a viz and tooltips to show the actual dots on the street to show that. Mapping other things just with some custom shapes. I did the shootings, mass shootings in a period of time in the United States. A little somber of a topic. Something a little more fun, the way that our internet connects us across the world, submarine cables, and how those submarine cables connect, our world. Again, this is a shapefile that literally takes 3 minutes to build in Tableau. Probably took longer to format the map than it did to plot the lines. So relatively easy to create. Again, this is on my Tableau public page. I also mapped ship traffic, and somebody else had done this, and I recreated it in Tableau and then played with it and did some other fun animated stuff with it. On the left-hand side of the screen, hopefully some of the animation is showing by hour. This is ticking, showing all of the shipping traffic coming into the east coast of the United States. And on the right-hand side of the screen, minute by minute on New Year's Day in 2017, all the ships minute by minute time lapse to kind of show you the traffic coming in the coast. That brings me to beautiful trash. This was a viz that was on the long list of the Kantar Information is Beautiful Awards, and I wanted to map my trash routes. And so I started with an animated viz that just looked at my trash routes and just showed my trash routes over time. Again, I don't know how this is going to show over the WebEx. It's probably not as smooth as it is in person, but happy to share links to this. There's a YouTube video for this as well. And you can see the trash trucks moving minute by minute using GPS location. The city knows exactly where they are, and we can kind of see them building out over time the roads through the street level locations. But I wanted to make this personal. I wanted to dive deeper into the data, and so I created a viz where somebody could click on their day and see when the trash trucks come to pick up their trash. And so you're going to want to make it personal. If your trash day were Tuesday, then you'd want to click on Tuesday. If your trash day were Thursday or Friday or Wednesday, then you'd want to click on those days and see the trash route for those days. And so it makes it very interactive, and you can see your route of what day your trash is. This is a preview of session that's going to happen at the Tableau conference. Chris DiMartini and Tomas are going to be talking about some advanced topics of things you can do in Tableau, and this is brand new. This is using a tool called Kepler, and Chris has created my trash viz that you just saw using Kepler, and this is Kepler inside of Tableau. There's now an extension available in the extensions gallery for using Kepler in Tableau, and a lot of fun, great way to map data, give you interactivity inside of your Tableau server or even Tableau online, I think. So hopefully this feature maybe someday will come to Tableau Public, and maybe we'll be able to even do some more advanced stuff, right in Tableau with tools like Kepler. This one is movement of device, people moving around Cincinnati looking at their devices, and this is June 1st of this year, minute by minute. What caught my attention was downtown Cincinnati, just a cluster of people, and I realized that there was a baseball game going on June 1st, and the baseball game starts at about 4 o'clock in the afternoon. So this is a Mapbox map of in Tableau using the animation pane minute by minute, and you'll see before the game they kind of kind of hit the area where the bars are and the restaurants, and then as we approach 4 o'clock, the stadium gets filled with all the people, and then as the game is done, they leave. I took that same data and put it in Kepler, and so this is not Tableau. This is a Kepler visualization, but it's that same data that you just saw in Tableau, and now with the extension that we have, we can bring Kepler into Tableau. We actually can now do this inside of Tableau as an extension, so kind of fun, and we'll bring some new power to Tableau mapping for sure. The last one that I thought I would end with is our buildings in Cincinnati. This was also on the long list of the Kantar's Information is Beautiful Awards. Was Biz of the Week a while back this year. And I just decided to map all of the homes in Cincinnati by the age. It was inspired by another visualization I saw by Nathan Rui, and decided to build this in Tableau and do some fun stuff with it. And you can drill down and look at the neighborhoods and see the age of the buildings and see kind of which neighborhoods are new. You can even do it down to the individual house and see which blocks are kind of added. Areas where there's new home development are sort of in the blue and purple and kind of stand out from the yellow where those are older houses. But the real fun comes when I animated this over time. We think about the 1800s is really when this city was founded, and downtown really is the area where they're living. As we get into the 1900s in here, we really start to build out the suburbs and kind of see the suburbs. As we get into the 1920s, that's after World War I, and you know, we start to build out more of the suburbs, but it's really not till World War II in the 1940s and 50s that we're really building out the suburbs, and now that we're kind of getting purple all over the map into the 80s and the 90s and the 2000s, where Cincinnati has really kind of expanded out into a very large city and to what we have today. So I thought I would end with that. Hopefully that animation played well over the WebEx. Hopefully I showed you some fun mapping stuff in this segment. I think that leaves me with just time for questions. So happy to take questions, and I'll turn it back over to Sagar.
Thanks a lot, Jeffrey, for that. I think some great advice and some great tips and tricks which we can follow. Everyone, lines are open for questions if you have for Jeffrey. So before that, maybe Jeffrey, I can ask one question from my side. So it's about, for someone who's just starting with Tableau, what will be the 3 tips you will have for him?
As it relates to mapping, my tips would be mapping is so easy in Tableau. You can just double-click any geographic field. You'll see a little icon of a globe, and you know that Tableau picked it up as a geographic field. And so double-click that field, you'll get a map. And so that's how easy it is to do with mapping. The second thing I would play with would be the map layers, because you can do a lot of fun stuff with the map layers. They used to give you 3, light, normal, and dark, and now they've added 3 more, which include built-in satellite, built-in streets, and outdoors. And the streets and satellite is really, really well done. You don't have to connect to Google Maps to do satellite anymore. So that's another handy feature. And then the formatting of the maps is really kind of fun to create other formatting, whether you want to link to something like Map Box and do some crazy maps that you can do all kinds of things, or you can just make it simple and take off your base layer and play with your pane color, and you can do all kinds of fun formatting right inside of Tableau without even connecting to Map Box. So I guess since my topic was maps, my 3 tips on quick tips on mapping.
And the next question I have for you is that you mentioned about Shapefiles. So any recommended resources and website you want to share it with the community?
Oh wow, Shapefiles are all over the internet. Almost anything you can imagine, people have probably created Shapefiles for. So very easy to get. Google searches will probably get you Shapefiles. I was hosting Makeover Monday earlier this year, and the topic was rhino deaths in Africa national parks. And I mean, it took me maybe 10 or 15 minutes, and I had the Shapefile. I found it. It took me a little while to Google. I've spent more time on Google than anything else, but eventually, you know, with a few Google searches, I found the national park in Africa. So just Google Shapefile, one word, Google what you're looking for, and just, you know, type in United States rivers and streams Shapefile, and it'll probably come up. There's loads and loads of shapefiles out there.
The next question I have for you is that how exactly you differentiate when you're designing something for a business or for an organization, right? Or something for fun? Like what exactly should I have in my mind when you're designing something for a business or when it's just for Tableau public with respect to map?
Well, you know, when I start a visualization, I think regardless, unless I'm building a tutorial on how to do something, if I'm building a visualization, I'm starting with two questions. Who's my audience? What's my message? And the who's my audience is going to dictate some of that. It's going to dictate what chart types I might use. It's going to dictate the level of detail that I'm going to do. Am I talking to the executives who I want a very, very high level overview, or am I talking to an operational person who does the work, who needs a lot of the detail? And so depending on who that audience is and what I'm trying to get across in the message of the visualization, that kind of drives all of that stuff, and that'll drive how much detail I put on the graph, chart, or map, or how I summarize it, the chart types that I'm going to use. Now, sometimes on Tableau Public, we do things just for fun. You know, we'll make a clock or a timer, or we'll curve bars, and sometimes we do that just to learn, and sometimes we do that just for fun. And so, you know, certainly there's a place for that. I'll just show you my Tableau Public profile page, and you'll see all kinds of things on there that are probably not standard chart types. You know, maybe it's out-of-the-box things. But interesting enough, you think about something like, okay, you're building a clock in Tableau. You know, what value is that for anybody to be able to do? And the answer is, well, without the math to do that clock that's running right there in Tableau, to get the hands on the clock, I wouldn't have been able to do the cell phone viz for the major cell phone provider that wanted the radial math for their cell phone signals. So there's sometimes real-world applications that cross over these things we do in the Tableau Public realm. So I would encourage people, have fun on Tableau Public, explore on Tableau Public. At the end of the day, if you're trying to create a visualization that you intend for people to use, then you ask yourself, who's the audience, what's the message, and what's the best way for me to communicate that message in the visualization that I'm creating.
Perfect, thank you. And can we build our own shapefiles?
You can. You could use a geographic software like ArcGIS. There's an open source one called Geoda, and so you absolutely can. And you can also bring those shapefiles into Map Box as a layer, and then bring your Map Box map into Tableau. So there's lots and lots of different variations that you can do with those shapefiles. You can layer them in, say, for example, in Map Box and have separate layers, and then you could bring those layers into Tableau, you know, as your map layers. So lots and lots of fun stuff there.
I'm just waiting for a last question. So like if anyone has a last question, we can just take it. Otherwise, we can just wrap it up. We are good to go. I think no one has any questions now. But thanks a lot for this session. I think it's a great session for some great tips and tricks. We loved your session, and I think we are looking forward to hear you in Tableau conference.
Great, thank you very much. Yeah, my session at Tableau is on Friday. I think it's 2:15. It's a 2-minute Tableau tips and tricks on how to do things in Tableau in 2 minutes. And I'm doing that session with Luke Stanky, who hosts the Workout Wednesday, and fellow Tableau Zen Master. So we'll have some fun tips and tricks, some things that you can do very quickly. We'll have some tips for all levels, beginner, intermediate, and advanced, so covering all kinds of fun stuff. And so look forward to seeing everybody at conference. Thank you for having me.
Perfect. Thank you. Have a great weekend. Take care. Bye-bye.
Bye.